All right, ready? Okay, so we have this 30, 60, 90 triangle on here, correct? And if this angle that we're looking at is the 30-degree angle, can you label the opposite, the adjacent, and the hypotenuse for me? Which side's the opposite?
The one on the far left.
And what's the length of that? Like numerical value? 1/2. Right? Okay, what about the adjacent side? Bottom side, and how long is it? Root 3 over 2. And the hypotenuse? What length is it? For the unit circle, it's 1. Okay, so all of these triangles, if we drew a triangle anywhere on the unit circle, the hypotenuse will always be 1, right? Okay, now we're going to connect it to SOHCAHTOA. So what does sine mean? So sine of an angle is opposite over hypotenuse. So sine of 30 degrees is what's opposite? 1/2. And hypotenuse? What is 1/2 over 1? 1/2. So the sine of 30 degrees is 1/2. All right, you could also type that in your calculator. Your calculator will say 0.5. That's great. Now go to your chart on the next page, and under the sine column, you're going to put 1/2 for 30 degrees. Okay, so sine of 30 degrees is 1/2. Can you tell me what cosine of 30 degrees is? What does cosine mean? Okay, so what's adjacent? Root 3 over 2. And the hypotenuse? 1. So root 3 over 2 over 1 is root 3 over 2. So cosine of 30 degrees is root 3 over 2. So add that to your chart as well. And how does the sine of 30 and the cosine of 30 relate to the parts of the unit circle you already had on your circle? Sine and cosine make up the point. Which one's which? X is cosine and y is sine. Yeah, because sine is opposite, and that's the part of the triangle that's going up and down, right? And then I said that wrong. The y value is the sine, which is the part that's going up and down, the opposite side. And then cosine is the adjacent side, and that's the part that's going side to side in the x direction. So cosine is the x value. So on your chart, above the sine column, I want you to write a y, and above the cosine column, I want you to write an x, because I need you to remember that all of the y values on the circle are the the sines of that angle. And all of the x values on the circle are the cosines of those angles. So the sine of 30 degrees is the y value, 1/2. Stop it.
Yes, ma'am.
The cosine of 30 degrees is the x value, root 3 over 2. All right, what about for 60 degrees? So this is 60 degrees. The y value is root 3 over 2, and that's the opposite. That's the sine of 60 degrees. So on your chart, under 60 degrees, in the sine column, it's root 3 over 2. The x value right here is 1/2. That is the adjacent side. That's the cosine value, right? Because all of them, the hypotenuse is 1. So if you do opposite over 1, it's just opposite. If you do adjacent over 1, it's just adjacent. What about 45 degrees? They're both root 2 over 2. So both sine and cosine of 45 degrees is root 2 over 2. Okay, So we've got sine figured out. We've got cosine figured out. That will follow all the way to 360 degrees. So you can follow your sine chart if you get all the y values around the unit circle through 360 degrees. That'll be your full sine chart. If you do the same for cosine, it's all the x values, right? So let's talk about tangent. What does tangent mean?
Adjacent over hypotenuse.
Opposite over adjacent. So for 30 degrees, what is opposite? 1/2. And what is adjacent? √3/2. Good. Now, those halves can cancel. All right, just like if you had a 2 and a 2, they would cancel. If you have a 1/2 and a 1/2, they cancel. So I can cancel this and this. What does that leave me with? 1 over √3, and then I would have to multiply top and bottom by √3, right? Yes, so add that to your tangent column for 30 degrees. Now I want you to notice that this 1/2 was the y value, right? And this √3/2 was the x value. So tangent can also be referred to as y over x, or y is the sine value and x is the cosine value. So tangent is known as sine over cosine. And that's actually its most common definition, is that it's sine over cosine. So in the tangent column at the top, I want you to write either y over x or sine over cosine. So you can take every sine value and put it over the cosine value, simplify whatever you have, and that will be tangent. So for 45 degrees, √2/2 over √2/2 is 1.
What is wrong with you, bro? You haven't been.
Okay, for 60 degrees, we have √3/2 over 1/2. The halves can cancel. What does that leave us with? √3/1, which is just √3, right? This is the reciprocal because these are switched. Did you notice that?
Nope.
Okay. What is cotangent? How is cotangent defined? It's adjacent over opposite because it's the reciprocal of tangent, right? So cotangent will be x over y, or the reciprocal of tangent, or cosine over sine. There's a lot of ways you can define cotangent. So let's talk about it as the reciprocal of tangent. If tangent is 1, 45 degrees, what is cotangent?
Negative.
What does reciprocal mean?
Just one.
You just flip it. It's still 1. Okay, I told you these were reciprocals of each other, right? So cotangent is also reciprocal of tangent. So if tangent is √3/3, cotangent is √3. You can flip it and go through the steps, but you'll end up with √3. And then the reciprocal of √3 is √3/3. Okay, what do you know about secant? Or sorry, cosecant. Let's talk about cosecant first.
Cosecant is y. So I mean, would it be x?
Cosecant is the reciprocal of sine. The reciprocal of sine. So we can call it 1 over sine. So if sine is 1/2, what would cosecant be? 2. What about secant? What is secant? Secant is 1 over cosine, reciprocal of cosine. So if cosine is 1/2, what is secant? Now these other reciprocals that have radicals in them we'll have to do a little bit of work with, but once we do it for these first 3, we'll notice that a pattern will continue for the rest of the chart and the rest of the circle, okay? So reciprocal of √2/2 is 2 over √2, right? And then I would have to do this. And I get 2 root 2 over normal 2, right? And that'll cancel. So it's just root 2 for this one, and then another root 2 for this one. And then root 3 over 2 is gonna have the same sort of situation. We flip it, we get 2 over root 3, and then we'll have to multiply by the root 3's. 2 root 3 over normal 3, and that can't be simplified. But that's the reciprocal of this and this. It is, and a lot of 3's. Okay, the last section I want us to talk about is 0 degrees and 90 degrees. So if sine is y, what is the y for 0 degrees? 0. What is the x for 0 degrees? 1. That came from the unit circle, right? What does tangent mean? Sine over cosine, so that's going to be 0 over 1, right? 0 over 1 is 0. Now here's one you may or may not know, the reciprocal of sine. So the reciprocal of 0 is like if you did 0 over 1 and then flipped it, you would get 1 over 0. Do you know what something over 0 is? Undefined. Okay, and then secant is the reciprocal of cosine. Cosine's 1, so what is secant going to be? Also 1, because the reciprocal of 1 is 1. And then cotangent. Why is it undefined?
Flip. So if flip it gets 1 over 0, right?
Because it's cosine over sine, so 1 over 0 is undefined. Okay, so your challenge now is to try to fill out the rest of this chart. You should notice some patterns and some repetition, but with some negatives mixed in, okay? That's your goal in this, to fill out this chart and look for some patterns and some recognition.